Today, let us look at one and another most important aspect of physics, which is mechanics. No student of physics will ever escape mechanics in the study of physics. Mechanics is the first module to be taught in high school and, of course, in fresher years in universities. The knowledge is also essential to the basis of understanding how rocket works as well as astrophysics study. Let's treat mechanics in the most easy way. Now, what is mechanics? Mechanics is the branch of physics that deals with the study of motion. As we all know, every animate and inanimate objects either move or subjected to move in the universe. The startup of planets and other associated bodies in the orbit started from concept of motion as well. A very good example is either voluntary movement of humans or involuntary. And of course, there are some cases when man also tried to exercise the body. So these are all forms of movement. Branches of mechanics. Mechanics can be divided into two areas, and we can study them independently of each other. The areas are kinematics and dynamics. Kinematics is the study of motion of objects with no reference to forces. That is, objects are studied with reference only to their motion, while we are less concerned about the forces that either start or stop the motion in a particular body in study. Now, let's look at another important terminologies and concept you need to be aware of in the study of motion. First is scalar quantity. Scalar quantity are quantities that have size or magnitude, and hence there is no need for other information to specify them. So they have no direction. Some examples include measurements of a particular length like 10 centimeter, and of course 60 seconds for time, and let's say 25 kilograms for a particular mass of an object. All of these are scalar. They are just magnitude of a particular object but no direction. So also is distance. Distance is also a scalar quantity. Now let us look at another one, almost opposite and a complement of scalar quantity, and this is known as vector quantity. Vector quantities have magnitude as well as direction. Example, a boat on a river moving northward or eastward, and of course an associated wind that is blowing either from the east or west. Now let us consider and look at this simple example here. There is definitely a difference between distance and displacement. Distance is one of the examples of scalar quantity, while displacement is an example of vector quantity. For illustration purposes, let us look at an example here and consider this problem. Now let us consider this example to throw more light on the differences between distance and displacement. If an object travels from point A to point C via B, it will cover a distance of 12 kilometers plus 10 kilometers as shown here. So if you want to move from here to here, it means you have to pass through air and air. So now the total distance is 22 kilometers as shown. But however, if you want to find the displacement, it is a journey of A to C, which is a journey around here. And what we need to find is just S, which is the hypotenuse. So the hypotenuse is calculated by using this Pythagoras theorem formula, which we are very familiar with. You know, you find the square of the hypotenuse to be square of the either other side, the adjacent and opposite. The opposite being 12 and the adjacent being 10. So they will give you, if you add them, you get for 244, and then you can find the square root of 244, which will give you 15.6 kilometers. So this one summarizes the fact that at every point in time the displacement is lower than the total distance, and of course it focuses on direction, as earlier said. Speed is the distance traveled per unit of time. We embarked on one form of journey or the other, and in the process and based on urgency, it determines our mode of getting there. Simply, speed is the distance per unit time, and the formula for speed is S, which represents speed, is equals to d over t, where d is distance and t is time. So let's do a little mathematics here, and I promise not to bore you with mathematics every time. So this will be very simple. It's a mere arithmetic. So I left conversion factor out of all this. So a car travel to a destination which is 200 kilometers away from a particular starting point in 2 hours. What is the speed of that car during the course of the journey? Your answer is simply distance over time, which is S is equal to d over t, which is 100 kilometers per hour. So as simple as that. Although the calculations will be given that will require you, probably you'll be given the population in minutes or seconds, and you'll be required to make a conversion between those calculations. But again, I want to leave that one to future lectures. You can see that physics is comfortable with mathematics anytime, and of course, it is a language that when you want to say anything, it is very easy for you to describe it or talk about it in physics using mathematics. Velocity is vector quantity, and it is how fast an object is moving and in which direction. Just like speed, we can calculate velocity almost the same way, but being a vector quantity, we need to also consider the direction. So let's look at a very cheap example as we do in terms of speed. Consider a car traveling on a straight line from home to supermarket, and the supermarket is 30 kilometers away, and it takes the car to get there in 2 hours. So what is the velocity? So the velocity, just like speed, is still 30 over the 2 hours. So the velocity is 15 kilometers per hour. But of course, the direction is towards the supermarket. Acceleration. Acceleration is literal meaning. Give a measurement and feeling of increasing something, either speed or delivery of an activity at a particular speed or speed. Yes, in physics, acceleration is the rate of increase in speed. So in acceleration, when speeding up is known as accelerating. That is, you are accelerating when you are increasing your speed from a particular low speed to a high speed. For instance, from about 40 kilometers per hour to 60 kilometers per hour, you are accelerating. If you are slowing down, it's called deceleration. For example, if you are speeding at 20 kilometers per hour and then you just come down to about 5 kilometers per hour, that means you are decelerating. Well, it is calculated conveniently by just considering the change in velocity. That is your final velocity, just subtract it from your initial velocity where you started and divide it by the total time taken. So, as in our culture, let's look at a very simple example too. Consider an object traveling at an initial speed of 5 meters per second, and of course it increases the speed to 15 meters per second in a speed of 5. So the acceleration will be 15 minus 5 over 5, which will give you 2 meters per square second. In some cases, per second square, or some people will also call it 2 meters per second per second. However, please take note that acceleration is measured in meters per square second, unlike other measurements. And of course, many of the calculation or many of the live examples will be given will be in kilometers an hour and or sometimes kilometers and minutes, and you will need to convert in between these two units. So there are conversion factors you must use, and of course I would like to treat that one separately in about 3 minutes or 4 minutes discussions, so that we'll be familiar with that. Now, I hope I have been able to introduce you to the concept of motion in physics, and this is also another background to prepare us for the real job to be done as far as physics is concerned, most especially when we begin to treat issues that borders on space and of course the distances between many of the celestial body to even the earth and of course in the orbit. So all of this together, we need to have this knowledge to be able to comprehend it as we begin to treat it. So thank you very much for your attention. I particularly want to urge you to please subscribe to this channel. This is a mere encouragement for us to be able to continue along this line. Subscribe and also share it and of course like it. Thank you very much.